Topic for today's session is significance of remote sensing and GS application in disaster monitoring and management. I think almost you have already heard about 8 sessions about disaster management. So I do not want to go into the explanation of what is disaster and other things, but I will be lightly touching upon it. And my focus of today's talk will be much on the fast growing technology, just is remote sensing and GS applications in disaster management and planning. Actually, the disaster management become a highly sophisticated and management process from the last 2 decades. Earlier to that, disaster management was not able to be managed the way in which it is managed today. From that point of view, it is very much appreciable because we have very good science and technology, that is the remote sensing and GIS applications, which is highly helpful for the planners, for the managers, and in order to control much of the loss of life and property. So just I'll be categorizing my talk into 3 sections. One is disaster, then about the remote sensing applications and how GIS is helpful in planning for facing the disasters. So these are the 3 aspects that I'll be going to cover today, and also the 4th one will be the what I have personally taken the project, the different projects, and the results that has been obtained. I'll be sharing with you those aspects also. So now to begin with, just a brief touch upon what is disaster. Means usually a disaster means it is defined by different authorities, different persons, different section of the academic society in a different way. But what we can easily define is whenever there is a loss of human life or injury to the human and loss of property, that can be termed as a disaster. Because without any loss to life and property, it cannot be called as a disaster. See, actually, there are many earthquakes, volcanoes, and landslides, and even if, for example, if hurricanes or tornadoes or cyclones, if it occurs over the sea, if the land, if there is a volcano or earthquake in the sea, that will not come into the highlight at all. It will not be news at all. So if the same thing happens in the human habitat where the people are living, that becomes a very big news. So I think you might have understood what I'm been focusing, because if it is happening in some remote corner of the world where there is no any human life, even if the animal life is killed also, that will not become a big news. But whereas if the human life is disturbed, or if anybody is killed, or if there is a loss of damage to the property, that becomes a big news. So we can say that a disaster means when there is a loss of life and property, that becomes a disaster. So here there is a small definition. A disaster is a sudden or unexpected event that causes widespread damage or loss and
Excuse me, sir. Excuse me. The
is
slide is not moving.
slide is not visible.
Sir, slide
Not
visible,
moving. Not moving.
but move ಮಾಡಿಲ್ಲ sir.
Can you can you see the slide moving?
Sir, first slide open ಇದೆ.
Slide are seeing not moving. Not moving.
Next slide ಹೋಗಿಲ್ಲ ಸರ್.
I have to call the technician here. Let me not meddle with this.
A title page open ಇದೆ sir.
Hello. Hello.
Sir, active.
ಅಲ್ಲ ಅವ್ರಿಗೂ ಬರ್ತಾ ಇಲ್ಲ ಅಂತ ಹೇಳ್ತಾರೆ.
ಹೌದಾ sir?
ದೊಡ್ಡ ಬರ್ತಾ ಇದೀಗ
Open ಇದೆ ಸರ್ ಬಟ್
ಬರ್ತಾ
ನೆಕ್ಸ್ಟ್
ಇದೆಯಾ?
ಸ್ಲೈಡ್ಗಳು ಮೂವ್ ಆಗ್ತಾ ಇಲ್ಲ.
ಸರ್ ಈಗ ಮೂವ್ ಆಗಿದೆಯಾ ಸರ್?
ಇಲ್ಲ ಮೇಡಮ್ ಆಗಿಲ್ಲ.
ಓಕೆ.
ಮೇನ್ಸ್ ಟೈಟಲ್
ಇಲ್ಲ ಮೇಡಮ್, ಮೂವ್ ಆಗ್ತಾ ಇಲ್ಲ. ಸ್ಲೈಡ್ ಕಾಣ್ತಾ ಇದೆ, ಮೂವ್ ಆಗ್ತಾ ಇಲ್ಲ.
Okay, sorry. Actually, I think my voice was audible and you have heard about what I explained. Is it clear now?
ಸರ್
Okay, I just defined what is disaster in my own way. That is, when there is a loss of life and property, that becomes a disaster. Even if there is a loss of animal life or some damage to the environment, if it is not, if it is a remote corner of the world, it will not be considered. Not considered means it will not become a major news in the media. So a disaster is a sudden or unexpected event that causes widespread damage or loss and exceeds the community ability to cope. Means when we lose our ability, say for example, if there is a huge rain, immediately we'll rush into some shelter, take some measures in order to come out of that particular unexpected event. But when we fail to cope up to the unexpected event, then that becomes a disaster. Disaster can be caused by natural, man-made, or technological hazards, because disasters can be classified into two major categories, like natural disasters and man-made disasters. Natural, you know, that is which is produced from the natural means, and man-made, it is out of the greed, and we are highly turning our own living environment into a great disaster. So a disaster, now my slide is not moving. I don't know what is happening. So characteristics of disaster. What are the characteristics of disaster? Means it is suddenness. Means suddenness, unexpectedly, when we encounter with a great threat to our life, it can be called as a suddenness. Disaster happens suddenly and unexpectedly. Then the magnitude. So whether the disaster magnitude is of significantly high at the level of damaging the property or the human life, that is another characteristics of disaster. And impact, it can be whether its impact is widespread and it is only on human or material, economy, or environmental losses. And the scope of disaster is if it is immediate or localized or widespread or long lasting. Say for example, the tornadoes occur for a few days and it will definitely subside. The earthquake, it will occur for a few minutes and it will subside. So there are other disasters like the climate change disaster that will be long lasting. So likewise, the disasters are of various characteristics, and the examples of disasters are earthquake, hurricanes, flooding, tornadoes, the nuclear power plant leakage, what has happened in Japan in 2011. The nuclear power plant was destroyed due to the tsunami. Actually, the earthquake hit the land and the earthquake produced the tsunami, and the tsunami hit the nuclear plant. Actually, it was unexpected. Japanese are very much very good in management of disaster because they are frequently encounter disaster. But this particular event which occurred in 2011 was out of their imagination, because the earthquake produced the tsunami. Usually tsunami, they are very much ready to face the tsunami, but at that time the water entered into the nuclear plant and the whole power went off and the leakage started. So it is the man-made disaster. Yeah, it is a man-induced disaster. Likewise, the there are various human intervention disasters are there. And the effects of disaster means human losses, including death and injuries, material losses, including destruction of physical assets, economic losses, including damage to sources of livelihood, environmental losses, disruption of basic services, and development of diseases. So these are the various phases of disaster. So with this, I just wanted to stop talking about the various aspects of disaster. Now I'll be moving on to this how disaster are managed in today's world with the help of remote sensing and GIS application. So I think most of you might have heard about the remote sensing. Remote sensing is a technology which is what means it is a technology where the satellites provide the information about the land or the earth surface. So that is the major aspect of the remote sensing. Is it clear? So you do have any doubts regarding the disaster, what I have talked about? If you have any questions, because I would like to have it as an interactive session rather than one man talking and the rest of you being just listening. So I always welcome if you have any questions so that we can have it as an interactive session. And so if you can interrupt me in any point of time, I don't mind. Everything is clear for you? Hello?
Yes, sir. Yes, sir. Yes, sir.
Okay. So remote sensing is used in disaster management to monitor, warn, and respond to disaster. It can be used at all phases of disaster management, including prevention, preparedness, relief, and reconstruction. See, in a disaster, we have different phases. Like, first of all, we had to have an inventory. Inventory means it is totally research based. We had to find out where exactly the disaster is caused, what is the magnitude of the disaster, what are the factors that are involved in the development of a disaster, and what is the possible techniques or measures to prevent it, and also how we can be prepared in order to face the disaster, and what relief we can give, because broadly the disaster are classified into three phases, that is off, pre-event, on-event, and post-event. In pre-event, again, two classifications. What is the pre-event classification means? Off pre-event study, on-event or sorry, actually this is we study the region by sitting at our own place, that is off spot study, on spot study, that is pre-event we can have a on spot as well as off spot. Off spot means when we are, if I am looking at a particular disaster region from my own office, that is off spot, and I am not on the spot, but I am studying about that particular area. On spot means going to that particular place and studying before the occurrence of disaster. So first of all, we had to make a research and find out which are the places that are susceptible or vulnerable for disaster, whether any kind of disaster, maybe landslide or earthquake or volcano or tornadoes or cyclones or a forest fire or landslide, any kind of a disaster. First, we had to study off spot, that is off spot inventory. Then this is pre-event disaster management aspect. Then we had to go to the spot and we had to conduct some study. After that, on the event, we had to do some of the work. So that is actual preparation, means what preparation we have already done before the event, that will be helpful for us to manage at the time of the disaster. Because if you are not prepared, say for example, today it is cloudy or today is sunny. So what you will do before coming out of the home, you will prepare for that. If you are not prepared for the, say for example, if there is going to be rainfall, means you will come prepared with a umbrella or raincoat or something. You will be having a preparedness for to avoid from getting wet. So that kind of a preparedness will be there only when we are means we can we can have a preparedness only when there is a warning or there is a information about it. For that reason, we had to have a first time knowledge or the research work should be done. So this is what the including prevention, preparedness, relief, and reconstruction. So up to preparedness, it is so the whole thing is the pre-event management only. So I had to first how to prevent it, how to prepare for the event, how to give relief, how to reconstruct the destroyed places or damaged places. All this can be done before the event and getting prepared, keeping ourselves at the war mode or keeping ourselves in a ready mode, ready to face the event. So all this can be done before the occurrence of the event. So on the event, we had to do certain things, and after the event, we had to give relief and the reconstruction should be done. So if you have planned very well for all these things, then your management will be very much successful and people will not be having that much of chaos or actually any people who have undergone into a disastrous situation, they will be having a lot of agony, they will be depressed, they will be having a lot of anxiety and all kind of feelings will be there, and it is all based on the level of your preparedness management that is going to be diminish or reduce the burden on the people's mind. So with this, these are the aspects that we can cover from the remote sensing and GIS application, because now we can very meticulously plan for the event without having giving scope for any kind of lapses in management, because the management aspect is totally based on the person who is exactly doing a research-based activity, because we had to identify the places of vulnerability, where it is exactly it's going to occur, what will be the magnitude, if it is the magnitude of this scale, what should be the type of preparedness, and what is the on-event preparedness, what should be the after-event relief providing and reconstruction. All these are all it can be well managed only when we have a very good information. Information is the most important aspect. So where does we get this information? We cannot go and collect from different offices of our departments, different various departments, or from the people, or it is very difficult and tedious task. Whereas the remote sensing has provided this information. Remote sensing is a very powerful application where it provides a very accurate and solid information of any places for that matter. So what are the applications that we can really manage with the remote sensing means, first of all, the monitoring. We can do how the events have occurred over a particular place over the time, and what is its magnitude is. So remote sensing can monitor the event that could lead to disasters such as droughts, floods, and cyclones. And warning here refers to the, as I said, that when we give a particular warning or a correct warning to the people, then there will be no any kind of damage to the, at least damage to the life, but property we cannot really control. So this warning has helped a lot to secure the life of the people. So remote sensing can provide early warning of disasters such as floods, forest fires, landslides, and earthquakes. What is the response? How we are going to respond to the disaster? Remote sensing can help emergency responders identify areas that need immediate attention and determine the safest routes for evacuation. So even not only the place where, yes, is there any question? So I didn't get you. Can you be louder? One of the participants. Is there any question? No?
ಸರ್ ಇಲ್ಲ ಸರ್ ಮಿಸ್ ಆಗ್ಯಾರೋ
Sir, continue, sir.
ಕಂಟಿನ್ಯೂ ಮಾಡಿ ಸರ್ ಅಲ್ಲಿ.
Okay, yeah, this is a response means we can, as I told you, it is not only limited to the identifying of the place of the disaster occurrence spot, but also how to evacuate, where to evacuate, where to rehabilitate. All these measures can be taken through remote sensing, and that is we see through the planning. Remote sensing can help plan the distribution of relief materials and the deployment of emergency responders. Then risk assessment. What is the total risk that is involved in a particular disaster? So how much of risk is involved? Whether it is for the people living in the area or the people who are going to that spot as a what volunteers, rescue team. So we can assess that risk also. So overall, from A to Z of disaster can be well managed by these applications, remote sensing and GS application. That is what I would like to stress upon. So how it works, remote sensing can provide real-time information about disaster over large areas. So remote sensing provides real-time information about disasters over large areas. So the beauty of the remote sensing is you can study over the larger area, or even you can focus your management aspect to a very small area also. So with the use of remote sensing applications. So this information can be combined with data from other sources such as maps, measurement stations using geographic information system. So in a brief, I can say that remote sensing application itself is not a ultimatum to provide a good solution to the disaster, but it also requires another application, that is geographical information system, through which we can able to get a very good output. Because let me go to the next slide. So here in this slide, you can see there are four aspects. So the first one is, this is the remote sensing information data. It is the satellite data. So this is a part satellite image of our Mysore. This is Chamundi Hill. Can you see my cursor? The movement of my cursor? This is Chamundi Hill, and this is the city, and this is Kaveri River, and this is Kabini, and this is the Pinasipur. So we get this kind of satellite images, and these satellite images are nothing but the storage of information. Storage of information means it is a voluminous data is available from this satellite images. Just it looks like a plain picture or a image, but it contains voluminous data. So the main goal of a researcher or the planner is to generate data from the remote sensing images. Without generating the data from these satellite images, we cannot able to get good results for any objective or any goal that we have set in. So for this, you should have a very good expertise or knowledge about how to procure the satellite images, how to generate data out of it, and how to use those data. So this is a major aspect of remote sensing, because a remote sensing application means you will be getting data from various satellites, and there are various types of satellite information. Land information is available, sea information is available, climatic information is available. So there are various types of satellite images and satellite data is available. You had to be in a good position to know which type of information is required for me to manage this kind of a disaster. So here we see the satellite information is obtained, and that satellite information that is obtained, which is in the form of an image, which is in the pixel values, that has to be processed. The process, there is a software application. So applications such as Elda, Snap, Grass, Idrisi. So there are many applications which will be available in order to generate the data. This is a application software which will process the satellite images and generates the data. What the data that we generate out of the satellites, that has to be again used in another platform, that is JS application platform. So when we use the JS platform, we'll be going to produce wonderful maps and spots, which are the hotspots of cyclones, which are the hotspots of forest fire, which are the hotspots of landslides. So vulnerability zones we can extract. We can have hundreds of query and find out which is the most predominant place of flood, or which is the most susceptible area for landslide. So that kind of a final output can be obtained from the GS application. GS is nothing but Geographical Information System. So satellite images are the storage of information that has to be analyzed, that should be processed, and data should be generated. The data that is generated from this section, means from this platform, it should be brought into the GS application platform. In GS application platform, we are going to process the data and we are going to generate the actual required things, like whether it is to identify a spot or to identify the magnitude, to what measures that we can take. So all this can be done in the GS application platform. And finally, the disaster management will be the total outcome, or the output will be how to identify, plan, and mitigation. Mitigation means, what is mitigation? What is mitigation?
Measures taken to reduce the impact.
I didn't get you. Can you repeat it again with little bit louder voice?
Measures used to reduce the impact of disaster.
Yes, it is mitigation means to reduce the impact. So the reduce the impact of a disaster is mitigation, because we cannot totally control or stop. That too, especially the natural disasters cannot be totally stopped. So we cannot hold manufacture a huge umbrella in order to avoid all the people from huge rainfall, or we cannot just totally stop the jolting of the earth. Earthquake cannot be stopped, or volcano cannot be stopped, landslide cannot be stopped. So what we can do is we can mitigate it. We can reduce the impact to some level. What the process, the natural process that is occurring, to some level we can reduce, but to maximum level we can ourselves can means when there is something which is going to strike, if you are given the information, immediately you will try to avoid it. So in that way, the mitigation is a very strong way of escaping from the disaster. Is it clear? If you have any doubts, you can ask me. So this diagram again speaks about GS and maps in disaster management. GS maps in disaster management. So what are the things? As I already told you, the preparedness, recovery, and redistribution, prevention and mitigation, relief, response. So all these are all the different aspects of a disaster. So we can do a very good study, and we can be prepared for all these things with the application of these two tools. remote sensing and GIS tools. Is it clear? So I do not want to go into the details of this chart because see, prevention and mitigation means the scientific hazard analysis, the simulation and modeling and vulnerability analysis, risk assessment and mapping, and stock assessment. Relief means search and rescue, rubble and debris removal, logistics, the duration of relief supplies. So all these actions, each and everything, you can list it out and you can plan in your own room or in your own place. You can plan for any part of the world. Disaster management is need not to be to this. A person should be located in the same spot. He can plan for any part of the world, and for some corrections or in order to know the accuracy of your research output, you can go on to the spot. Usually going to the spot and knowing how far you are making a correct means your assessment is correct and decision is correct. You can go to the spot and take a decision also. That is also good, but you need not to be any person can be appointed, the local person to give the information about what you have obtained from your own chamber or in your own place of your research. So that is the another the major characteristic feature of remote sensing and GIS application in disaster management. So a person, if I'm given a project of how to manage the forest fire of any African country or landslide of any region of the world, I can sit from my own place and I can totally make a wonderful research output, and we can suggest it to the local planning body how to plan for it. So that is the major advantage of using the remote sensing and GIS application. So GIS, let me talk a little about GIS, and there will be a lot of things that I will be showing for you. So geographical information system links location, spatial data and database. Location means without pinpointing to the space, any information will become useless. Suppose if I do not say a particular place, and if I just give the all other information, that becomes a useless information. So when I pinpoint or when I specify the land exact point on this earth, then that data holds all value. I think you're getting my point, because the spatial location is too important, and the information attached to it is also again important. Only when you specify the place and then you provide the information of that place, it becomes more useful. Say, for example, if you write all everything of your home address, and finally if you miss the city where you are living or the area where you are living in a city, that information becomes useless. So nobody can reach out to your point. If you do not say that if you, while writing all the address about Mysore University, and if you forget to say that Mysore University is located in Mysore, or if you do not mention the University of Mysore, all other information what you provide becomes nothing. So for that, the space and the data is very much important. The spatial data and the space, because when you attach the or tag the information to a particular point or a place, we always in the GIS language speak in terms of a point. Point means it is a lat long coordinate. A point is nothing but a lat long coordinate. So each and every point will have a specific information, and it will be unique information. So only when you point out to a particular point and talk about that particular spatial point information, it becomes more valid. So it will be the information can be in tabular form. Means, as we know that we use different types of data, which is in the tabular form. So college information will be in tabular form. So all population information, agricultural information. So also this information about the land and the various aspects of the land can be in a tabular form. And when those land and the land information is clubbed and analyzed and retrieved with a query, that becomes the most useful information. I think you have understood what I am talking about. So it gives the relationship and trend also. So studying about two places gives the relationship. Studying about the same period, same place for different periods, that is also again, it provides a very good trend of that place, what is happening for last 20 years or 30 years or 40 years or 50 years. So we can generate a wonderful information, output. The final output can be very much useful when we are linking the information to the space, either comparing to two different regions or studying about a particular place for different time periods. So here you see in a GS we have the hardware, the all computer components. The software, as I already told you, the GIS software applications like the ArcInfo, ArcGIS, and MapInfo. There are many GIS software applications. Then we have the vector data, raster data, the all pixel data, means pixel raster is nothing but pixel data. The vector data is nothing but the, as I told you, the coordinates system, the coordinates of X and Y value, and the methods what we are going to use. What are there are different methods because we have the overlay technique analysis, shortest path analysis, network, because there are various types of analysis are available in analyzing a particular regional data. So what method you are going to, because this is very too much important, because many people, because this software, what it will do, whatever the data you provide, that will provide a map or it will provide an output. But how far the generated output is correct or true to the exact land on the ground, that can be measured only from the terms of the accuracy. Accuracy can be known only from the method. If your method is correct, then your output will be right. If your method is wrong, your output will be wrong, because when you generate the information, say for example, if I let me take the Chamundi Hill of Mysore city. If I want to see the susceptible landslide spots of Chamundi Hill, and when I do a analysis, if my methodology is right, I will be able to point out the exact spots of landslide. Suppose my methodology is wrong, I will not be able to get this exact spot. The spot where exactly landslide will be occurring, I will not be showing it in my map. I'll be showing some other place, and that place will not be a place of landslide. It will be having a very stable land. So this kind of a wrong analysis and wrong output should not be generated. For that reason, method should be very much important. Method should be very much proper, correct. So ultimately, it will come to the use of people. People means like the end users, whether it can be institution or a taluk or a village or whichever may be the part of the study. Means it can be the whole Karnataka, or it can be district wise or taluk wise or obli wise or village wise. So ultimately it will be the people who will be involved, means the whole GIS, because without the final input, the end of the result should be useful for the people. If the people are not ready to accept your results or your method of managing, then that is of no use. So the GIS have got all these components, hardware components are involved, software components are involved, the database should be created, and the methodology should be very much perfect, and it should be helpful for the people. The people should be the end users, and it should be giving a kind of relief to the people. Is it clear? So if you are quite clear about what I have explained so far, I will move on to the next slide. Is there any questions?
No, sir.
Okay. So let me touch upon remote sensing, because I'm given a very brief introduction about remote sensing without going to the specifications of it. I'll not be dealing with the technical aspects, because the technical aspects of remote sensing is too physics oriented, and we cannot, we are not that much interested. It will not be helpful for us, because building a satellite, launching a satellite, and operating a satellite from the ground station. All these are all the technical aspects. So what we are interested is only the data that has been captured from the satellite. Is it clear? The data that is captured from the satellite is important, and only from that aspect or from that level onwards, we can focus our interest in knowing about the remote sensing applications. So techniques of obtaining information from a remote place, that is information about an object, area, or phenomena from a distance. So usually we call our remote control TV remote control. Means sitting at a very far off place, we can switch on, switch off, and also control means we can change the channels. We do all types of remote control. So also the remote satellites are also controlled in the same way from the ground station. And what it does, it collects the information of an object, a particular object, or area, or a phenomenon. So whether it's a phenomenon of the air circulation, or the phenomena of the water circulation, the phenomena of the forest fire. So we can do all sort of study from a remote place. As I already told you, sitting at this room, I can do a study of any place, because the data has been available and the data has been collected through remotely. So through the satellites. So why is remote sensing useful? Large regions can be observed over time. So what is the major benefit of the satellite data means? It will be observing the larger area over time. Suppose if I want to know the total land information about Mysore district means, I had to, even if I tour for nearly a month or 2 months, I'll not be able to cover up all the things. But a satellite can give or provide a wonderful information for a larger area. And it can be repeated also. It is not one time. Say, for example, we have topographical maps, which is surveyed one, which is man-made one. So that is one time. It is done in some 1920s. 1920s, the survey has been conducted and they have published. We are just simply updating it. 1971, we have updated again. Every time we are updating it without going to the spot. We are without going to the region. That is through, again, aerial photography, they are updating. So this is not like that. It is for a particular, on a particular spot, if you want to get the information, it can be repeatedly you can get. Say, for example, if you want to have the house building activity of your own house to be monitored from your own office place. Suppose you are stationed at a different place and your home is built at a different place. You can monitor your house construction through satellite information. So that is the major advantage of having a satellite image. Means now in America and many European and other Australia and Canada and other places, huge farmers are monitoring their crops through remotely or remotely managed. Means they do not go to the field, even whether the crop is dry or the insects have attacked or the pests are there. That can be done through, because now the agencies are come. Just if you give your land to monitor, they will take up the land for monitoring and they will do all sort of agricultural operations, and they will finally give you the final harvested crop. So you have to pay the money without having any kind of work. You can sit at home and your agency will do all the work for your land and get the final produce. So that is how the remote sensing can be utilized. Remote sensing information or the technology can be utilized for a very focused land or for a very larger area. So that is over time also. So what is there in this remote sensing is sensors. Sensors can measure energy and wavelengths beyond range of human vision. So what we see is a human vision. We are able to see what is exactly on the land or the ground or the in our own area. So whether it is land or sea, you will see what exactly is present. But in remote sensing, it is not like that. It is beyond our vision, human vision. What we cannot able to see, it can be sensed through the satellite sensors. So that is the major advantage, and it is one of the key aspect of the remote sensing technology. Records information in real time. Records information, because real-time data, it is very difficult to get. At the same time, all the information, all the places, at the different time period. So real-time data is a very difficult thing. Say what is happening right now in any part of the world, whether it is over the sea or over the land or over any city, that can be obtained by without any results. So that is the records information in real time. It is not only providing just the information of the present time, but also it will be recorded. So let me just, in this slide, I'm showing you. So how this technology is helpful from the global level to the very minute level, means micro level. So the satellites can cover the whole globe, and in that you can choose India for your study. In India, you can choose Karnataka. In Karnataka, you can choose the Chamarajanagar district as shown, Chamarajanagar district. In Chamarajanagar district, again, you can choose one taluk. In that taluk, you can choose one hobli. So this is how remote sensing technology can be from the global level to a minute village level you can able to study. And my talk is also in the similar form. I'll be talking about, I'll be giving various examples of remote sensing technology, remote sensing GS technology, how it has been used for my own project work, because I have worked for international projects, the Japanese 4 projects I have worked, and also I have done one desertification process of desertification in Karnataka. So I will be giving some of the output what I have got from my research. So do we have time, or it's already break 3 o'clock? At what time we had to break? 3:15 or 3:30?
More maybe, sir. 3:15.
3:15 we had to take break.
Again,
And
3:45 start
3:30 is break time. Again, we had to resume at 3:30. Okay, so 15 more minutes are there. So let me. Okay. 3:15 into 3:45, half an hour. Half an hour break. Yeah. Okay. So the slide what you are seeing right now is about the procurement of these information from satellite. So how this operates? The satellite information, how we can get it. So you find A. A is what? It is sun. Sun is the main source of light, and it is the main source of what it is the medium. Sun is the main source of medium through which the satellite technology is operating. So the sun rays, as soon as the sun rays falls on the land, the sun rays B, the sun C is the land. The sun ray is falling on the land. So as soon as it falls on the land means here I'm talking about it can be a open soil, or it can be a vegetative cover, or it can be a water body, or it can be a building, or it can be a road, or it can be any type of land. So what happens? Immediately the energy will be reflected. So all objects on ground. So if I'm using the term object means I'm talking about even the natural one. Yes, any? So when it falls on the ground, it will reflect. So the reflected light will have the waves, means the sun rays itself will have the wavelength, and this wave, when it is falls on the ground, and that will also again reflect back, and these reflected waves are sensed by sensor and it is captured by the satellite sensors. That is what we are seeing in this figure. So A is sun, B is the sunlight, and C is the land, and we see the reflected light is going back to the satellite, and the D is satellite. It is sensed in the, it is captured in this satellite. So immediately from D, it will come to the ground station. It will come to the ground station. Whatever the reflected values that is captured, the wavelength it is captured, that will be sent to the ground station. Sometimes it will be sent to the another satellite. From another satellite, it will come to the ground station. So it can be, say for example, our GPS works on this kind of a form. Means there should be minimum three satellites in order to get the exact location of a person, means GPS, global positioning system. So this information goes to this another satellite. From there, it will come to the ground station. So this is what will happen in the ground station. They just, it is only a scientific place where the data is as it is collected, stored, and it will be sent to the processing unit. Processing unit means whatever the signals or the reflectance values that is collected from the ground station, it will be sent to the F station. The F station will process those things and remove unwanted, because the cloud or the mist cover. So some of the unwanted things will be there. So the unwanted noises, we call it as a noises, that will be removed in this F station. And finally, it will be given to the users like us. So we are the users, and it will be further from the research aspect, we will be using it. After the research aspect, it will go to various other bodies, like the planning bodies, like the district administration or taluk administration or any other private agencies. So they can use it. So this is the actual form of how the satellite data is procured and processed and utilized. Is there any question in this? If you have any questions, you can ask. Otherwise, I'll move on to the next slide. Shall I move on to the next slide?
Yes, sir. Yes, sir.
Sir,
So in the sun energy, we have electromagnetic spectrum. So the sun is not only just emitting the light, but it is having a electromagnetic spectrum. So the electromagnetic spectrum is the base for the remote sensing. So if you do not have, if the sun would not have produced this electromagnetic spectrum, the satellite technology would not have been be there. So the remote sensors collect the reflected and emitted energy. Reflected and emitted. See, there are two things here, reflected and emitted. When a light falls on the ground, immediately it is reflected. When the same point is get heated, when it is, that itself will become a source of producing, means it will be emitting. What is it has gained from the sun, it will be discharging it. That discharging is called as emitted energy. So reflected is immediately without having any lapse, it will go back. So that is reflected. Emitted means what has been absorbed and released. So here in this diagram, you can find the, it is a leaf. So a tree leaf, how the energy is absorbed and released. So the incoming solar energy is falling on a leaf. Some amount of it is absorbed by the leaf. Some amount is reflected, and what is absorbed, that is emitted in a few, means time lag. We do not know what is the time. Means it will emit the absorbed energy also. So that is, so the incoming rays are reflected and it is reflected, and the absorbed one will be again discharged from the leaf as if though it is producing it. So that is called as emitted energy. So energy available for remote detection is from, it is, so both will be taken for our, it means the both the types of reflections are sensed by the sensor or captured by the remote sensing satellite sensor. Means the sensor, just like our smartphones have a camera, the satellite images have, satellites will have or fitted with the sensor. So that sensor will sense the reflected and emitted energy, and that data will be sent to the ground station, and the ground station process it and finally will get the exact or the real-time information. So let us know about the electromagnetic spectrum. So the electromagnetic spectrum ranges from the shorter wavelengths, including gamma, X-rays, the longer wavelengths, including microwaves and broadcast radio waves. There are several regions of the electromagnetic spectrum which are useful for remote sensing, because the electromagnetic spectrum is a very big range of wavelengths. In that, only a particular part of the electromagnetic spectrum is useful for remote sensing. Here is the the wavelength. See, higher the frequency, shorter the wavelength. The longer the frequency, the larger the means we have higher the frequency, shorter wavelengths, lower the frequency, longer wavelengths. So this is the total spectrum. In this we have the radio waves, the microwaves, the infrared, the visible waves, the ultraviolet waves, X-rays, gamma rays. So we'll see which are the visible spectrum are. So in this, we do not see the radio waves or microwaves or infrared, only the visible rays. This is the only seen our eyes can sense. Our eyes are also like a remote satellite sensors. So our eyes can able to see only this part. None of this, either radio waves or microwaves or infrared or ultraviolet, X-rays, gamma rays, all this cannot be seen from our naked eye. So what is visible spectrum? The light which our eyes, our remote sensors can detect is part of the visible spectrum. It is important to recognize how small the visible portion is relative to the rest of the spectrum. Means when you take the whole spectrum into consideration, the visible spectrum is a very, very smaller portion. Means we 1/10 of its only visible spectrum. Rest remaining 9 portion of it is not visible to our eyes. There is a lot of radiation around us which is invisible to our eyes, but can be detected by other remote sensing instruments and used to our advantage. So since we are not able to see those waves, whereas the sensors, the devices that we have developed, the scientific devices that can, the sensor, here the device means the sensor can able to detect, or it can able to capture that wavelengths. So that is the major advantage what we are having. So you can find here again. So this is all the nanometers, and we find the visible spectrum is only this much, whereas there is a very huge electromagnetic spectrum, and in this we find the Y rays, X rays, ultraviolet, infrared, microwave, FM, that is our radio waves, and AM, long radio waves. So we are many aspect of this we are not using, since the gamma rays, X rays, and all these are all we are not at all still using it. And this is the visible spectrum. So this portion is only the visible spectrum. You can see how small it is in the electromagnetic spectrum. So the visible spectrum has got a reflectance wavelength of 0.4 nanometers to 0.7. So the 0.4, the shorter waves produces, the most shorter waves produces blue color, whereas the longer wavelengths produces red color. And we find this in the rainbow. When the rainbow occurs, we see there is a Vibgayar. So we can find the entire Vibgayar here. So violet, blue, indigo, green, yellow. So Vibgayar, the whole Vibgayar can be seen, and its wavelength is in nanometers from 0.4 to 0.7. So as I've already told you, the visible wavelengths cover a range from approximately 0.4 to 0.7 nanometers. The longest visible wavelength is red and the shortest is violet. It is important to note that this is the only portion of the electromagnetic spectrum we can associate with the concept of colors. Means we know that this Vibgayar are the colors that are identified or that can be seen from our eyes. So Vibgayar. And this Vibgayar is again it has been put into 3 RGB, red, green, blue, because the red, blue, green makes 1 million color. The fermentation combination of because there are 256 red, 256 red colors, 256 green color, and 256 blue color. But our eyes cannot able to identify more than 10 or 15. Your eyes, if your eyes is powerful, you can able to identify some 15 types of red, 15 types of blue, 15 types of green, but it will not be possible more than that. So whereas the sensors can able to sense up to 256 types of red, 256 of green, 256 types of blue. So that is how the remote sensing data has become so powerful. So here you can see the Vibgayar, the indigo, blue, green, yellow. So all this cyan and red. So these are the wavelengths of the different colors. 0.4 to 0.46 is violet. Blue is 0.46 to 5. Green is 0.5 to 0.578. Yellow is 0.578 to 0.592. Orange is 0.59 to 0.62. And red is 6.62 to 0.7. So blue, green, and red are the primary colors of wavelengths of the visible spectrum. As I already told you, BGR or RGB are the primary colors. So from this, you can make any type of color. So 1 million colors can be, if you go to any paint shop, if you give any color, you will get you a combination of these three through the computer, and you will get you that color paint. So RGB makes 1 million colors. They are defined as such because no single primary color can be created from the other two, but all other colors can be formed by combining blue, green, and red in various proportions. So without these three colors, there cannot be more number of colors. Although we see sunlight as a uniform or homogeneous color, it is actually composed of various wavelengths. So we see the sunshine or the sun ray is one single ray, but it has got all these electromagnetic spectrum, as I told you, gamma rays, X-rays, ultraviolet rays, infrared rays, visible rays. So all these radio waves and all these things are all can be there in one single ray. So when it passes through a prism, if you keep a prism and if you make a sunlight to pass through the prism, then you will see this electromagnetic spectrum, and that is especially only the visible spectrum, not the all. So there is infrared region. Infrared region means actually, as we have seen in the electromagnetic spectrum, the infrared region covers the wavelength range approximately 0.7 to 100 nanometers. So that is one. That is 100 times as wide as the visible portion. Means the infrared portion itself is 100 times bigger than the visible spectrum. And we are using the infrared region for many applications. The infrared region can be divided into two categories based on their radiation, like the reflected infrared and the thermal infrared. The reflected infrared is available for thematic mapping. Thermal infrared is available for climatic information. So in the infrared, we have the near infrared, mid infrared, far infrared. So you can see this near, mid, far, and the reflected and MSU infrared and short waves. So the reflected and thermal infrared are most commonly utilized information now. And as I told you, this reflected infrared is useful for getting the land information, whereas the thermal information will be providing the climatic information. So the microwave region is another aspect which is giving the information below the the subsurface. So always we see that the visible spectrum is only limited to the surface. Means as soon as the sunlight falls, the reflected energy will be captured by the sensor. Not even 0.2 millimeters, it will not detect. So what is this? The object that is there on the ground, that immediate object reflectance value will be sensed by the sensor, but not the object which the underneath or the bottom part of that object information will not be there. I think you might be try to means if say for example, if there is a paper is sitting on a land, the paper, some waste paper or any paper. So that paper reflectance value will be taken by the sensor, but not the underneath of that paper. The bottom part of the paper information will not be, or the wavelength information of that land will not be captured. So that is in the visible spectrum. Whereas in the microwave, it goes deeper. This microwave goes deeper, and we get the information of the deeper land also. That is the major advantage. So for example, what is where exactly the water point is available, what is the soil moisture. So for all sorts of research, this microwave region is very much helpful. So in this satellite, we have two types of sensors, passive sensor and active sensors. Passive sensors are nothing but when the satellite is capturing the information during the daytime, it is called as passive, because the satellite will not be emitting any kind of energy in order to capture the reflected wavelength. What the energy that is emitted from the sun, that emitted sun reflected back is captured by the satellite sensors. So it is called as passive sensors. So you find the sun, and the sun sunlight is falling on the earth, and that is captured from the by the satellite. So this is active sensor. Here the sun is not in the picture. This sensor means the satellite itself will shed the energy, and it will get back the reflected value of that particular line. So this is active sensor. This is during night time. If the satellite is moving over the night time, it has to do active sensor. Means active sensor should be placed. So usually the satellites are launched in such a way that the satellites will take a path or orbit according to the sun shine. So it will be always moving in synchronized to the sun light. So there will be no issue of reflected value. Means the reflected wavelength will be always captured, because the satellite will be for moving along with the means Earth's rotation, and it will not have any means. It is only in a very typical and particular cases this active sensors are used. I think you have understood about active and passive sensors. And the satellites are launched. There are two types of satellites. One is geostationary satellite, another is polar satellite. Polar satellites are launched 800 kilometers and above, not more than 1,000 kilometers. Whereas the geostationary satellites are more than 30,000 kilometers. So you can just imagine 30,000 kilometers means how far it is. So from that height, the satellites will be collecting, or it will be sensing the reflected wavelengths. So geostationary satellites are useful for communication and TV. Means our television programs are all run through geostationary satellites. The major this one of geostationary satellite is it will be focused to a particular point on ground. Say for example, if the satellite is focused to Bangalore city, so it will be sending information only to that particular, and it will be always all the 365 days it will be focused to that particular point. So it is stationed, though it is not actually stationed, means it is not in a constant or immobility. It is moving, but it is moving synchronized to a particular point on the ground. So it will move according to the Earth's rotation and revolution along with the Earth. It will be moving. So it will be always focused to one particular point on the ground. Whereas polar satellites are, it will be revolving around the Earth. So this is the polar orbit satellites. This is geostationary satellites. Okay, so I will just take